Welcome to today's lecture. Today we'll be looking at balancing redox equation in acidic medium. The topic again is balancing redox equations in acidic medium. Now the redox equation to be balanced is heptanoxodichromate 6 ion plus thin 2 ion giving chromium 3 ion and thin 4 ion. Now we're going to go through a number of steps in order to balance this redox equation. I would like you to take note of each of the steps so that when you want to do yours, it will be easy for you to carry out. Step number 1. Separate the redox equation into two half equations. The step again. Separate the redox equation into two half equations. So then Cr2O72 minus gives Cr3 plus and Sn2 plus gives Sn4 plus. Step number 2. Balance all other atoms except oxygen and hydrogen. In other words, balance every other atom there, but don't touch oxygen, don't touch hydrogen. So let's go now. Chromium has 2 atoms here, but if you look at this place, we have 2 atoms of chromium, but we have 1 here. So in order to balance the chromium up, we put 2 here to balance the chromium. Tin, 1 atom, tin, 1 atom. Don't use the 2 plus or 4 plus. These are charges. Okay, the number of atoms here of tin is 1. That of tin here is also 1. So tin is balanced. Step number 3. For every atom of oxygen lacking, add 1 mole of water to the deficient side. Here we have 7 atoms of oxygen, so we add 7 mole of water to the deficient side. There is no oxygen here, neither is there any oxygen here, so we leave that second equation the same way. We go to step number 4. For every atom of hydrogen lacking, add 1 mole of hydrogen ion to the deficient side. And so we added 7 mole of water to this side. That has introduced 14 atoms of hydrogen. So that means we're going to be adding 14 mole of hydrogen ion to this side that is deficient of hydrogen. And then when you come to the second half equation, we do not have any hydrogen to balance. We go on to step number 5. Balance the charge by adding appropriate electrons to the more electropositive side. And so we have Cr2O72 minus 2, 14H plus, that's plus 14. Okay, and then we have 2 Cr3 plus, that's plus 6, 2 times plus 3, that's plus 6. This is not in the ionic state, so we take it as 0. And so if you look at this side, we have plus 2. By the time you resolve minus 2 plus 14, you have plus 12. And plus 6 plus 0, you have plus 6. So this is the more electropositive side, and by 6, so we add 6 electrons to the more electropositive side. Then when we come to the second half equation, here we have plus 2 and here we have plus 4, so it means that This side is more electropositive by 2, so we add 2 electrons. That's if you do 4 minus 2. The more electropositive side minus the less electropositive side. If you do that, you're going to get 2. And that gives us 2. So we're adding 2 electrons to this side. Step 6. Multiply the two half equations by appropriate integer to cancel out the electrons. You have to carry out this carefully. Here we have 2 electrons. We will use these 2 electrons, the integer 2 there, to multiply the first half equation. Here we have 6 electrons. We use 6 to multiply the second half equation. However, in order to reduce the burden of multiplication, we look at the 2 integers. We see that they are factors, so we can cancel them out. 2 here, 1, 2 in 6, 3, and then we use that to multiply out. So if we use 1 to multiply this out, 1 times that will give us Cr2O72 minus 1 times 14H plus, that will give us that. 1 times 6 electron will give us 6 electron. 1 times 2 Cr3 plus will give us 2 Cr3 plus. 1 times 7H2O will give us 7H2O. Then when we come to this side, I want you to look at the electron is on this side, so we have to transfer the electron to this other side after multiplication. So let's take it gradually. 3 times Sn2 plus will give us 3Sn2 plus. The electron, we are transferring this electron to this other side after multiplying. So 3 times 2, that's minus 6 electron by the time you transfer to this other side. And then 3 times Sn4 plus will give us 3Sn4 plus. I beg your pardon. This is 4 plus. So you add up Cr2O72 minus 14H plus 3Sn2 plus 6 minus 6 electron gone. So we have 2 Cr3 plus 3Sn4 plus. I beg your pardon. This is 4 plus, then plus 7H2O. So this is our balance redox equation in acidic medium.